Welcome to Physics 30 Prep Fast Track, Lesson 4-1, Period and Frequency. An object that repeatedly undergoes the same motion is said to be oscillating, and it can be the circular motion of a clock, the hands of a clock, whether it's the second hand, the minute hand, or even the hour hand, are all undergoing circular motion, and it would be simple harmonic motion. So vibrational, hummingbird's wings, and even more complex, something like your heart beating. Each type of motion above is an example of simple harmonic motion. And to describe simple harmonic motion, we use the terms frequency and period. So frequency is the number of vibrations, whatever type of vibration they are, an oscillation, rotation, repetition, and so on, that take place in a given time. So revolutions per minute is a certain number of revolutions in a given time, in this case 60 seconds or a minute. A hertz, or a cycle per second, or sometimes called an RPS, is a number of revolutions in 1 second. Alright, so those are both examples of units and definitions of frequency. Period is the inverse of frequency. So if you have so many vibrations per minute or so many cycles per second, the inverse of that is so many seconds per vibration, or so many hours per vibration, or so many days per year, as in the period of the Earth as it goes around the Sun. The period is 365 days. So period is the time it takes an oscillator to complete one cycle. And the units can be time, any unit of time, seconds, minutes, hours, and so on. So we can practice these two concepts by looking at a simple example. A pendulum or tire swing oscillates back and forth 7 times in 5 seconds. What are the frequency and period of this swing? So, of course, we use our two definitions for frequency and period from the previous page, and we say that frequency is the number of events in a given period of time, in this case 7 events or 7 oscillations in 5 seconds, and we end up with 1.4. And of course, if you look at the units, there's no real unit up here other than oscillations. The unit here is seconds, but it's in the denominator. So we say seconds to the -1. And that is the unit of the hertz. The per second, or the second to the -1, or we often call this the hertz. All right? And of course, the period is the inverse. Instead of number of events in a given unit of time, it's the time for a certain number of events. We like to put it down to the time for one event. And so you take your 5 seconds for 7 oscillations, and you get 5/7 of a second, or 0.714 seconds. So that is the period of this particular oscillator. So the frequency is 1.4 hertz. The period is 0.714. And notice that they are the inverse or reciprocal of each other. So we often say that frequency is equal to 1 over t, t is equal to 1 over f. They are the inverse of each other. And so as the frequency gets smaller, the period will get bigger, or vice versa. As the period gets bigger, the frequency will get smaller. Let's look at another example. It says the pistons in a diesel engine have a move up and down with a frequency of 62 hertz. What are the frequency and period of the pistons? So they're telling you that the frequency is 62 hertz. Well, of course, that's cycles per second. So to convert cycles per second to revolutions per minute, we want to take these units. 62 hertz means 62 cycles per second. Now, of course, to convert seconds into minutes, there are 60 seconds per minute. And of course, when we multiply 62 by 60, we get 3720. The seconds cancel the seconds right here, and we're left with cycles per minute. And of course, cycles per minute is the same as revolutions per minute. So you can convert hertz into RPMs by just multiplying by 60. Now to find the period of this, of course, we know that the frequency is equal to 1 over t, or in other words, the inverse of the period, and the period is equal to the inverse of the frequency. So if we go back to our 62 hertz, 1 over 62 is equal to 1 over 62, and that gives you 0.016. So if you've got 62 hertz, that means you have a very small period of only 0.016 seconds, or 16 thousandths of a second. So frequency and period. Notice the two types of frequency, hertz or RPMs. All right, these are equivalent but certainly look different. And the period is 0.016. So radio stations give their call signals in hertz. One popular radio station is 100.3. So what is the period of the radio station's wave? Well, if the frequency is 100.3, now the radio station gives its frequency on the FM dial usually in megahertz. So this is 100.3. Mega means times 10 to the 6, and so really it's 1.003 times 10 to the 8 hertz. That's the frequency of the radio wave. All right, it's an electromagnetic wave that leaves the station. So if that's the frequency, then of course the period is the inverse of the frequency, and it's 1 divided by 1.003 times 10 to the 8, which is very, very small. Only 9.97 times 10 to the negative 9 seconds. And this is a small time period between oscillations of the radio wave or the electromagnetic radiation. There are a couple of examples of the difference between frequency and period, and we'll use both of those terms when we start to develop the universal wave equation in another lesson.